Assalamualaikum and a very good day to everyone. So in this record, we are going to talk about alternating current circuits. So from previous chapter, we have learned about induced EMF in a coil. So here we have a coil. Right, by rotating a coil in a magnetic field, it will produce an induced EMF that varies sinusoidally with time, as in this figure. The induced EMF change with time, and it also generate an alternating current that change with direction as it varies with time. So in this chapter, we will discuss all these contents which use this AC source as supply of energy in the electrical circuit. And interestingly, it is interesting to know that many electrical appliances in our house are actually connected to alternating current circuits. Okay, we will start with explanation of AC sources. As we know that AC source is produced from the coil that is rotated in the magnetic field. In electric circuit, this is the symbol used for AC source, right? And we know that the AC source always varies with time. The voltage varies with time as well as the current varies with time. So if by referring to this figure, right, the expression of the voltage can be described by this function. Okay, we have delta V here is the instantaneous voltage, which measured the voltage at a specific or at a instant time, right? And we have delta V maximum, which is defined as the maximum output of the voltage source. For example, in this curve, here the peak is the delta V maximum, the voltage amplitude of the source. And then we have omega. Omega is the angular frequency of the AC voltage, or mathematically it is defined as 2 pi f. It depends on the frequency. Okay, same goes to current. The expression of the current from this curve, it is given by I equal to I maximum sine omega t. And these instantaneous current are varies with time. Okay, next we will look at phasor diagram. An alternating voltage and alternating current can be presented in a phasor diagram. So this phasor diagram is actually show the relationship between current and voltage from the circuit as vector addition of the phasors. So for example, we have AC source here, right? Okay, and it is represented by delta V phasor. Here we have delta V phasor, and as this source is on, switch on the source, alright, the power will be moving through the circuit. So the current is represented by phasor I. So a phasor is a vector whose length is proportional to the maximum value of the variable represented by delta V maximum and delta I maximum. So in this diagram, the length of this vector is the maximum voltage or the maximum amplitude of the source. So same goes here, right? The length of this blue arrow indicate the maximum value of the current in the circuit. So you will use this phasor diagram to show the relationship between voltage and current in the circuit, in the AC circuit. Okay, we go to the first element. We have resistor in AC circuit. So you have resistor connected to the AC source, right? So remember that the voltage across the resistor is equal to the voltage from the AC source. So as such, we have this function, right? The voltage across the resistor is given as the voltage from the source, and it is a alternating voltage. Okay, so that is the instantaneous voltage across the resistor. So next we want to find the instantaneous current in the resistor. So by applying Ohm's law, we have V equal to IR. So I, the current in the resistor, is given by voltage across the resistor divided by resistance. So now we know the value of delta VR, right, which is equal to the alternating voltage of the source. So you plug in here and you will get this function. And we know that delta V maximum divided by R, delta V maximum divided by R is equal to the I maximum current in the circuit. So now we have equation for the instantaneous current in the resistor. Or you can write it, the instantaneous voltage across the resistor, right, in terms of resistance. Again, we have this function, right, and we know that V maximum is equal to I times R. So just plug it into equation 1. So you got this function. Okay, next we want to see the plot of the instantaneous voltage and instantaneous current with time. Okay, so based on equation 1 and equation 2, function of voltage with time as well as function of current with time. Okay, so we will plot the curve. Okay, based on equation 1, we have V maximum sine omega t. So it is a sine function. So this is a curve for the voltage, the orange color. And the purple curves represent the alternating current of the in the resistor. It is also in a sine function. Okay. So by evaluating this plot, we can see that the current is in phase with the voltage, which means that the current is 0 when the voltage is 0. The current is maximum when the voltage also maximum. So this is called in phase. Okay, next we can transfer this plot into a phasor diagram. So this phasor diagram shows current and voltage phasor for the resistive circuit at some instant of time. Alright, so from this phasor we can see that the current and the voltage are in same direction. Alright, so meaning that both are in phase. So this is how you draw the phasor for these two quantities. Since both are in phase, right, both current and voltage are in phase, so the direction of the phasor also must be in the same direction to show that both quantities are in phase.